Hello again. Now, we are talking about friction, finally, okay? We see these coefficients of friction. When you see coefficients of friction, you need to write to yourself what's happening. F net is equal to is a way we write what's happening. Side note, for those overachievers, another way of writing it is the sum of the forces in the x direction are equal to. That's for those overachievers, though. So the idea is that we're going to list all the forces on the other side of the equation. Now, if that doesn't make sense to you or that went over your head, ignore it, okay? We don't care. We can get rid of it, and we will just get rid of that here. Let me see how I can do that. Where's the thingy for that? Nope. Oh, whatever. I don't know where that thingy went for it. So I'll go back to this. So we're going to say F net is equal to, and I'm going to list the forces. But in this case, think about what's going on. You have a car. Here's my car. It's moving along and hitting sand. There's nobody pushing or pulling the car. So the only force acting on the car when it hits the road is friction. Okay, that's it. Now, after you list your forces, F net's equal to, and list your forces on the other side, we substitute the equations underneath. The equation for net force is MA. The equation for force of friction is mu mg. Now, what we can do is we can cross out the m's. I found where that thingy was now. All right, and I'm going to have acceleration is mu times g. Mr. Spudik, what do I use for my mu? I see two. I see mu kinetic and mu static. Don't get caught up on static is sitting still, kinetic is moving. Because in this case, the static friction, if you have static friction, your wheels are doing the right thing and rolling on the road. When you have kinetic friction, that would mean your tires are skidding. Skidding tires have a lot less friction and will take a longer time to stop or a longer distance. So when it says the shortest possible stopping distance, that means you want to use the static friction here. So in my case, I'm going to do 0.125 times 9.8 to get my gravity or to get my acceleration. Okay, I'm going to multiply that out for you. So I get 0.125 times 9.8, and I have an acceleration of 1.225 meters per second squared. Okay? Now, what do we do from here? Well, now we're going to say hello to our old friend, the VF squared equation. And we are going to solve for the displacement, how far it traveled. So, we're going to subtract VI squared from both sides. So I have VF squared minus VI squared is equal to 2AD. And then I'm going to divide both sides by 2A. Yoink, yoink. All right, I'm going to move this up a little bit. Doop, doop. All right, so what do I have? I have VF squared minus VI squared divided by 2A is going to be equal to my displacement. So I have the final velocity is 0. Okay? So my initial velocity was 19.6. So I have 0 minus 19.6. Don't forget to square it. Divided by 2, divided by 1.225. Okay? Make sure both numbers here, the 2 and the 1.225, should be together. So if I had just a basic calculator, I would be doing, and this acceleration will be negative. Okay, don't worry about that. It's just that's going to be a positive answer when you're done. So I'm going to write in 19.6 squared divided by 2 divided by 1.225. Woo! Do that. Go back to 5. And I will get whatever answer I get there. Let me see what mine is. 19.6 squared divided by 2 divided by 1.225. And I get 156.8. And you are so welcome, and thanks for watching.